Okay, so for secant of 120 degrees, what do we do? See, inside the parentheses or outside the parentheses? Outside. Remember that x negative 1 is saying 1 divided by the cosine. And we get for that, -2 works for me. Cosecant of 170, we do that by using what? Sine of 170, inside or outside with the x negative 1? Outside. Which is going to give us 5,759. Tangent of 230 degrees. Well, that's just tangent of 230 degrees. 1.192. Let's go the other direction. If the cotangent of angle A equals 3.4, find A. Or if the secant of angle B equals 5.2, find B. And if the sine of angle C equals 0.934, find angle C. Okay, so for number 4, how do we find that? Cotangent uses what trig function? Inverse tangent we're going to use because we're finding the angle. Then what? The x negative 1 is inside the parentheses. So it is inverse tangent since we're finding an angle. Now we do the 3.4, the x negative 1 is inside the parentheses, giving us 16.39 degrees. Does that look right? Number 5, for the secant of B, what function do we use? Inverse cosine. And again, the x negative 1 is inside the parentheses with the 5.2. 78.91 degrees. Sine C of 0.934, we're just going to do inverse sine of 0.934, which gives us 69.07, we'll call it, degrees. Anybody have any questions on those? What's that? Well, just like we did before, if you've got here what's the angle that you're looking for, it's an inverse trig function you have to do. So like for sine here, we have sine of angle C. Sine of C is equal to 0.934. It's just like solving an equation. Just like if we had 3C equals 12, how would we solve that? Divide by 3, exactly. Well, here, the variable C has not been multiplied by something. We've taken the sine of it. Here it was multiplied by 3. We divided by 3 because division is the inverse of multiplication. It's the opposite. Well, here, to get rid of the sine, we have to do the opposite. And the opposite of sine is inverse sine. So we do the inverse sine of each side. Inverse sine and sine cancel out. That gives us that C is equal to the inverse sine of 0.934. And we just calculate that on our calculator. Since that is a sine, it's just second sine to get inverse sine. 0.934 is the 69.07. The other ones are a bit trickier because those aren't straight up functions. Where I use a secant, let's say I have a cosecant of d equals 1.8. Well, to solve that, I have to get rid of the cosecant because the variable d has had the cosecant taken out of it. So it's an inverse cosecant. So again, the inverse cosecant and cosecant cancel out, leaves me with just the d equals the inverse cosecant of 1.8. So the difficulty here is we don't have a cosecant button on our calculator. So for the cosecant, we use the sine. Remember, cosecant is 1 divided by sine. So what we can do is we can just do 1 divided by the inverse sine of 1.8. Actually, that doesn't work. It has to be the inverse sine of 1 divided by 1.8. Which is the working backwards on the 1 over sine. Well, instead of doing the 1 divided by 1.8, we can take a shortcut. We do d equals the inverse sine, and we just put in the 1.8 and do x negative 1. That x negative 1 key is saying take 1 divided by that 1.8. That's what that's saying. It's just a shorter way of entering it. Something we have mentioned. Looks a little bit like this. Sine of 150 degrees. If you calculate that, what do you get? 0.5. Well, what if I tell you that the sine of angle A equals 0.5? How do we solve that? Inverse sine. What's your calculator give you when you do the inverse sine of 0.5? 30 degrees. Well, I thought sine and inverse sine reversed each other, undid each other. But it says the sine of 150 is 0.5. But if I do the inverse sine of 0.5, it gives me 30. Why is that? Well, we're back to this unit circle thing. "30 degrees" would be right here. Its sine is the length from here to here, and that length is 0.5. But there are other spots on this unit circle that have a sine of 0.5. If I trace this here straight across, right there, that's also a sine of 0.5. The terminal side of that angle would be right here. What angle is that defining? 150. Where do we get 150 from? Yeah, this right here has to be 30 degrees. If that's going to be 0.5 here, we have to draw it such that this triangle and this triangle are the same triangle, just mirror images of each other. So if this is 30, this had to be 30, which makes this, as Dave said, 150. The 30 degrees here, and here is what's referred to as a reference angle. The diameter across here, remember we called that a reference diameter. It's the reference diameter partly because it's the horizontal diameter, but also because that's the diameter that all of our angles can be referenced from. Now there are two other spots here other than 30 degrees and 150 degrees. There are two other spots that have a 30-degree reference angle. One of them is down here, so that should meet at the same spot there. That's 30 degrees. What's that whole angle going to be? 210. And there'll be one over here. That angle would be 330. Very good. If this is 30 degrees, that's just 360 minus the 30 gives us 330. Over here, if that's 30 degrees, it's 180 plus 30 gives us the 210. And one of the unique things about those reference angles is angles that have the same reference angle. So I've got 30, 150, 210, and 330. If I go to calculate their trig functions, they're going to be related. Now we've already said the sine of 30 degrees is 0.5. The sine of 150 degrees we found a little bit ago to be 0.5. Sine of 210 degrees, negative 0.5. Very good. Sine of 330 degrees, negative 0.5. So it's the same length, it's just these two are below the axis, so they're in the negative range. Cosine. Cosine of 30 degrees is 0.866. Cosine of 150 degrees. Now remember, this is the positive side for the cosine. This is the negative side. 150 degrees would be negative 0.866. Cosine of 210. That's negative 0.866. And cosine of 330, positive 0.866. You got it. So you can see if angles have the same reference angle, their sine or cosine is the same number, it just only could be different by a positive or negative. This used to be way more important than it is now. The first calculators didn't do the sine or a cosine of an angle bigger than 90 degrees. Now your calculator, you can punch in sine of 1,087 degrees, and it'll find the sine or cosine of it. Even before the first calculators, they used tables to find the trig functions. So they would actually have a table that had all those functions listed out on it. In fact, I might even find one and show you here quick. See what we pull up on a web search quick. So you can see something right there. There's a trig function table. Of course, this is given in a radian table, but here we go. These are the ones I'm more familiar with. So you can see this one. Ooh, that's not what I want. Yeah, there it is. So it lists it from 0 degrees up to 45 degrees. This one goes by 5s up to 210. And actually, no, it doesn't. It goes from 0 up to 90. You can see it's listed up to 90 up here. The reason it allows you to go from 0 to 45 and then from 45 up to 90, remember that co-function? You know, the sine of 10 degrees is going to be the cosine of 80 degrees. So you can use those co-functions to find those other angles if you need to. So let's say I want to find, you can see down here they've got the functions switched. This is labeled cosine and sine, or here it's labeled sine and cosine. Well, if we're using this set of numbers, we use the top labels. So the sine of 5 degrees is right here. But if I want to find the sine of 80 degrees, well, that's not on this side. I have to go to this side to find 80 degrees, so I use these labels. So sine is this column now. of 80 degrees. So you had to know those co-identities, and since this table doesn't go above 90 degrees, you had to use those reference angles. And you had to know, okay, the reference angle, the 284 degrees, I'm looking up a 76 degree reference angle. And it's going to be negative sine and positive cosine because of where it's at on the unit circle. So those identities and reference angles used to be very important. Now, not so much. But the reference angles are very important to us in one respect, because tomorrow we're going to start solving more complex triangles. And as we solve those triangles, I'm looking for missing pieces. We're going to run into spots where we have an inverse sine of an angle, but the angle we're trying to find is an obtuse angle. So we might look at a triangle like that. And if you know that this angle here has a sine of 0.6, well, there's two different angles that could be. Your calculator, when you go to find 0.6, you do the inverse sine. It's going to give you 36.87 degrees. That's obviously not 36 degrees. It's obtuse. So it's going to be 180 minus that answer. 143.13 degrees is what that real angle is. So we're going to look at that a lot more tomorrow. Okay, for today, I'm going to get you guys going early on your homework. This is the last page of the packet you have. Page 374. There's 1 through 12 there, which is just finding angles, or finding the trig functions, actually all 6 trig functions of those angles. Sine, cosine, tangent, cotangent, secant, and cosecant for each of them. Make sure you get them correct for positive or negative. And if there's anything else in this package you need to go finish up, I'll let you have this time to work on those. As I said, tomorrow we start oblique triangles. Everything we've done so far has been right triangles. Oblique triangles don't have right angles.